Alright, welcome back to another video on my channel, math_exe. Today we're going to look at perimeter and area of plane figures or 2D shapes. So there are many 2D shapes or plane figures that I'm going to talk about and discuss about the formulas and stuff. So first we're going to start with the square. The square has 4 equal sides and I'm just going to call this length S. And the perimeter is given by 4s, or in other words 4 times the length of its side, and the area is s squared, in other words the length of the side of the square squared. So that's it for the square. Next we're going to talk about the rectangle. The rectangle has 2 pairs of equal angles. Equal sides. So I'm just going to call the first side, which is the longest one, which is L for length, and the shortest side is B for breadth, or sometimes called width. So the perimeter is 2 times in the parentheses L times B. Now I'm just going to recall that the perimeter is the distance that you need to cover around the figure to get back to the original place. So here's what I mean. So given you're standing right here, and then you want to go around at this distance right here, and then to go back right here. I'm just going to draw this. There we go. So the question is, how far or how long is this distance? So that's it for the perimeter. And the area for a rectangle is just the length times its breadth, or L times B. And we're going to look next at the triangle. Now there's different types of triangle. There is an isosceles triangle, a equilateral triangle, and a scalene triangle. However, I'm just going to choose the scalene triangle because this formula can be used for any other triangles as well. So like I said, the perimeter is just the sum of all sides, which is A, B, and C given here. And the area of this triangle is a half times base times height, where the base, which is B, must be perpendicular to the height H. So that's one keynote to keep in mind with. Next is the parallelogram. Not only it has 2 pairs of parallel angles, it also has 2 pairs of equal parallel angles. Parallel sides, it also has 2 pairs of equal sides. And I'm just going to call this B and A, as shown there. So the perimeter is just 2 times A plus B. And the area here is B times H. And again, we need to ensure that the breadth is, the base, in this case, it is what it's called. The base is perpendicular to the height. The second last one is the trapezium. And as you can see, it has a pair of parallel lines. And the perimeter of a trapezium is just the sum of all its sides. So in this case, it's just A plus B plus C plus D. The area is a half times A plus B, where A and B are the line segments, or the length of the line segments of the parallel lines, and then all of that multiplied by H, which is the height of this. And again, we must ensure that the base, or in this case A, or possibly any of those parallel lines, must be perpendicular to the height H. Now you must be careful to not mix things up between whether it is A, B, C, or D. Just keep in mind that A plus B here is, or this thing right here, a half times a plus b, is just the average of the parallel sides, or I would say the average of the length of the parallel sides. So you don't really need to memorize the letters and stuff. You just need to like understand what it actually stands for. And the last one is the circle. And this drawing is not necessarily a perfect circle, so I apologize for that. And some quick things to note: that the diameter of the circle is 2 times the length of its radius. And the radius is the distance from the center of the circle, which is commonly denoted as O, to any point on the circumference of the circle. And what I mean by the term circumference, I mean the perimeter. The term circumference is another word for the perimeter of a circle. So P, or sometimes denoted as C for circumference, is pi times d, or 2 pi r, while the area will be pi times r squared. And pi could be approximated using one of these, so we have 3.14 or 22/7. And these are only approximations for pi because pi is an irrational number. That means the decimals are going on forever. And these are the rough, almost exact approximation, but also the simpler one. Alright, so that's it for all these formulas and the shapes that we need to talk about for this. Let's jump into some examples. And it involves a semicircle and a quadrant. And a quadrant is just another name of a quarter circle. So we need to find the perimeter and area of this shaded figure in red using the approximation of pi equals 22/7. So probably I'm just going to start with area because it's probably easier and probably the most obvious. So the area of the shaded figure, I'm just going to call this call this box in red, as if this resembles the shaded figure, is actually the area of the quadrant minus the area of the semicircle. And remember, the formulas for this is pi times r squared, where r is the radius of each part. However, since these are not perfect circles, and a quadrant or a quarter circle, as its name suggests, is a quarter of a circle, therefore the area is a quarter of the original circle. And in this case, I'm just going to call this radius r1. And for the semicircle, it's half of the area of the whole circle, which is this, and I'm just going to call the radius of the semicircle to be r2. And keep in mind, we're going to use the approximation of pi to be 22/7, and r1 is the radius of the quadrant, which is just for 14 meters. Alright, and then we have a half times 22/7 times the radius in this case. Well, if you look at this, this length is also 14 meters. And if you notice that this length right here is not actually the radius, but it's actually the diameter. Therefore, we can just divide it by 2. That means the radius of this will get 7 meters. Alright, so let's just substitute that in. I'm just going to use the black for this. Alright, notice some simplification of these fractions. So this will be 11/14 times 14 squared is just 196. And don't forget the units. This also cancels to be 11 on the top. 7 meters squared is just 49 meters squared. This cancels and this cancels to make this a 14. This cancels and this cancels to make this a 7. Now overall this will give us 77 meters squared. And that's our answer for the area. Alright, for the perimeter, I'm just going to use some space and I'm going to erase this part right here, because I'm just going to focus on the shady part. So think it like this. You are standing on a point, a random point, on the perimeter of the shaded area. And you're just going to travel all around this shape, whatever the shape is, and go back to your original place. So what I'm going to do is to focus on one part of this journey, which is first on this arc right here. And keep in mind, this length right here is actually just the same as 14 meters. And this arc right here is actually a half of the perimeter of a semicircle. So I'm just call this perimeter of green. Is a half of the diameter. And the diameter in this case is 14 meters. And we take pi to be 22/7. So a half times 22/7 times 14 meters. So this will be 22 meters. And then we're going to travel in this direction in red. So this direction in red is just 14 meters. It's just pretty easy to see. And then finally, the last part of the journey is this arc. And this is the bigger arc of this quadrant. And since it is a quadrant, the perimeter of this arc is just a quarter of the perimeter of the original circle that was built in for this. And in this case, we're given the radius but not the diameter, which is 14 meters. However, that's not that hard to find the diameter because we can just multiply it by 2. So the diameter right here will be 28 meters. And substituting the approximation of pi as well, you'll get this is also equal to 22 meters. So in fact, the perimeter of this shaded figure is the sum of all perimeters making up this whole journey back to your original place, which is, so I'm just going to be total. It's just 22 meters plus 14 meters plus 22 meters. Which you'll get, this is 58 meters. So the perimeter of this shady figure is actually 58 meters. So that's the first question. Let's jump into the second one. Alright, so here's the second question. So this figure shows a rectangular paper ABCD and identical, keeping the keyword identical, squares AEFG and CHIJ cut out from the rectangle. The remaining area of the cutout rectangle is 168 centimeters squared, and we need to find the length of AE, which is this little bit right here, and the perimeter of the cutout rectangle after we found the length of AE. So let's just work this out slowly. So I want to suppose that the length of each square will be x, And I mean each square because we know that each squares are identical. So we can just form an equation in terms of x by noticing that the area of the cutout rectangle, I'm just going to draw a mini diagram right here, is equal to the area of the original rectangle minus the area of the two identical squares. So since we know the area of the cutout rectangle is 168 squared, 168 centimeters squared, and the area of the rectangle is just a length times breadth, which is 20 centimeter times 10 centimeters minus the area of the two squares, which is the area of one squared, which is x squared, plus the area of another square, which is also x squared, which will also make this 2x squared. So let's see what we have. So we have 200. So the left hand side first will stay the same. We have 200 centimeters squared minus 2x squared. Alright, let's see what we can do. We can subtract 200 centimeters squared on both sides to get negative 32 centimeters squared. And don't worry about the negatives because they will cancel out later. As you can see right here. There we go. That's very nice. So dividing 2 on both sides, we'll get x squared is equal to 16 centimeters squared. And taking the square root on both sides, we get x is equal to plus or minus 4 centimeters. However, we're in the world that we're supposing that distances are positive, so we're just going to take positive 4 centimeters for this. And since a square has 4 equal sides, that means this x right here will be equal to this length. Sorry, not that length. This length right here, which is AE. So therefore, we have concluded that the length of AE is 4 centimeters. Alright. And I'm just going to clear out some space right here. I'll be right back. For part B, we need to find the perimeter of the cutout rectangle. And we've just done showing that the length of each square is 4 centimeters. And with this, we can just find each line segment that kind of like makes out the whole rectangle. So let's see. So we know these and these are 4 centimeters. This length right here, which is GD, it's just 20 centimeters minus 4 centimeters, because 20 centimeters covers 4 centimeters and the length GD. So this will be 16 centimeters. And I'm just going to erase this arrow right here. And this length right here will be 10 centimeters minus 4 centimeters, which is 6 centimeters, as well as on here 6 centimeters, as well on here. So I'm just going to erase this arrow. This length will be 16 centimeters. And keep in mind, these are identical squares, therefore their side lengths are same. Right, so we're done drawing the sides that makes out this cutout rectangle. Now we're ready to find the perimeter. So the perimeter of the cutout rectangle is just the sum of all sides that make out this cutout rectangle. So first we have 16 centimeters, and when you're calculating perimeter with many side lengths, I would just suggest to work in one direction. And I mean in one direction, I mean you can just work things from add things clockwise or anti-clockwise. So you would want so you wouldn't miss some sides out. So 16 centimeters plus 6 centimeters plus 4 centimeters plus 4 centimeters plus 16 centimeters plus 6 centimeters plus 4 centimeters plus 4 centimeters. Alright, so that's a lot of centimeters right there. So overall, we'll get a result of 60 centimeters. Let's see if I got that correct, and in fact I did. Alright, so the perimeter of this will be 60 centimeters. And that finishes question 2. Let's jump into the third question. For question 3, here CED is a semicircle and ABCD is a parallelogram. Use the approximation of pi equals 22/7 to find the perimeter and the area of this figure below. So I should probably start with perimeter first. So notice that the perimeter here is just the sum of all sides that make up the figure. So we know two sides already, which is 35 centimeters and 9 centimeters. And by knowing that a parallelogram has two pairs of equal sides, that means this is also 9 centimeters. And all we need to do is to find this arc right here, which is in fact, I'm just call this P of CED. This is actually the half of the circumference of the circle that was originally built in, but this is just cut in half. So this perimeter of the arc here will be a half times 22/7 times the diameter. However, again, by using that the fact that a parallelogram has two pairs of equal angles, that means this is also 35 centimeters. So we can just quickly write that down. And there's some cancellations going here. This will leave us 11. This will leave us 5. Overall, the perimeter of this arc will be 55 centimeters. Alright, so the perimeter of the whole figure will be just the length of the sides that was built into this. So we have 55 centimeters plus 9 centimeters plus 35 centimeters plus 9 centimeters. Alright, so quickly evaluating this, we'll get 108 centimeters. Alright, so that's it for this perimeter. Now we're going to focus about area, and I'm just going to clear some space first before I work out this thing. Alright, for area, it's just the sum or the total area of the figures that built into this figure, which is in fact, I'm just going to write down the equation. So the total area will be the area of the parallelogram plus the area of the semicircle. Now the area of the parallelogram, I'm just going to draw another diagram of this with the exact same dimensions. So I'm just going to rewrite all of this thing. Alright, so notice that the area of a parallelogram is base times height, and we must ensure that the base must be perpendicular to the height, which in fact it is. So we can just use these two numbers to calculate this area. So we have 9 centimeters times 28 centimeters plus the area of the semicircle, which is just a half of the area of the circle that was built into this. Alright, and for the semicircle, we're just only given the diameter. However, that's not really a problem because we can just divide it by 2, and we're probably best to work in fractions because it will be very easy for cancellations later. So the radius here will be 35 over 2 centimeters. So overall this will be 252 centimeters squared, and this will be a half times pi is 22 over 7, or here is this thing right here squared. You can cancel the 2 with the 22. Now 35 squared is just 35 times 35, so 125. And then 2 squared will be just 4. And in fact, we're working in large numbers. And in fact, that we can just cancel out a 7 and a 125. And then after this, we'll just multiply that by 11. So overall, we'll get this will be equal to 733 quarter centimeters squared. So in fact, in this section where you have to calculate big numbers, you may use a calculator for this context right here. However, if you're not allowed to, you can just you'll be forced to calculate that using long division and stuff like that. Alright, so that's it for question 3. Let's jump into the fourth question, which I think is a bit challenging. So here wxyz is a square with xwz and xyz are identical quadrants with centers y and w respectively, as you can see right here. And that shaded figure is just the intersection of those two quadrants. Using pi equals 22 over 7, we need to find the perimeter and area of the shaded figure. So I'll probably start with perimeter, which is the easier one. So the perimeter of this is just this length right here, or this arc right here plus this arc right here. So let's just work things out. I'm just going to mark these with different colors. I'm just going to mark this with blue and yellow. So let's just work things out. So the perimeter of the blue arc will be equal to a quarter of the circumference of the circle that was originally built in this quadrant. So we have this thing right here, a quarter pi d. Although the diameter is not given, instead we're given the radius, which is 21 centimeters. We can just find the diameter easily by multiplying by 2. So we have a quarter times pi, which is 22 over 7. The diameter will be 2 times 21, which is 42 centimeters. So we can just cancel some things out. This will be 2, and this will be 6, and this will be 3. So the length of this arc will be 33 centimeters. So if you haven't noticed already, actually the length of the blue arc is equal to the length of the yellow arc. So instead we can just stop right here because we know they are equal. However, I'm just going to let you guys work out the length of the yellow arc just to show that are the same. However, you can just easily say that it's the same because they're identical quadrants. That means they have the same diameters. So that means the perimeter of the shaded figure, I'm just going to draw a mini diagram inside this parentheses, will be just 2 times 33 centimeters, which is 66 centimeters. And that's it. Now for the area, I'm just going to clear things up for this. Alright, so let's see. We can somehow form an equation for the area of the shaded figure. So let's just do that. So the area of the shaded figure is equal to the area of the square minus the area of the remaining parts, which are these things right here. And we know these are identical, which means their areas are equal because the quadrants are also equal. So instead, we can just write this as 2 times the area of this thing right here. So the area of the square is just 21 centimeters squared, which is just 441 centimeters squared. And we need to somehow find this. And we can just form this by another equation by knowing that this is equal to 2 times the area of the square minus the area of the quadrants. So if you can see by your eyes that this in fact holds true. So in fact, we also know that the area of the square is also 441 centimeters squared, and the area of the quadrant is just a quarter times pi times the radius squared, which we're going to work out later. So this will be I'm just going to write things out for the rest of it. Well, I'm just going to discuss mainly on the area of the quadrant. So we have a quarter times 22/7 times quarter, and we know that the radius of the quarter is 21 centimeters. So there's that thing right there. Then you have 4 squared times 2 times this whole thing. And you just have to or we this. And boom. And then let's see what you have. So 4 centimeters squared times 2 times this part right here on this thing. So this will be 4 centimeters squared. So the inside of this will be 2 times 94.5 centimeters squared. This will be 440 squared minus 189 centimeters squared. This will be 252 centimeters squared. And that's it. Alright, so that's the area of this. And often we need to kind of figure out doing some smart investigation and try to make some use of what we're given. Alright, so that's it for this video. So hopefully you guys enjoyed this, and please subscribe. I'll be doing more examples of these in the future, or probably in the next video. So stick out for that, and goodbye.